Okay.
Yep, there it is.
Okay, there you go.
All right. For sure. All right, so yeah, we are Team 125 from the University of Missouri-Columbia. As you can see, everything kind of laid out here, from nose to, don't mind the pieces, the middle tube, the coupler section, and then the aft tube with the fin set and the motor casing. But yeah. So starting at the front, this is our nose cone. It's a COTS nose cone with our 1/2-inch Kevlar cord, kind of bolted or into the actual bulkhead that's in there and fastened to the nose cone tip itself. I think it's a Mad Cow nose cone, 4-inch diameter.
Okay.
And yeah. And then we've got kind of laid out kind of our parachute bag here, kind of stuff that in there again. But it's an 84-inch. It's an Iris from Fruity Shoots.
All of the recovery hardware is all Fruity Shoots. So it's a 4-inch deployment bag, an 84-inch Iris into that deployment bag. So that's the main. We have a 20-inch pilot chute for the bag that you can kind of see next to it there.
Yep.
And the pilot chute is serving as your drogue, or does the pilot only come out at main ejection?
It just comes out at main ejection.
Yeah, at main ejection.
Do you have a separate drogue?
Yes, we do. On the other half. So this is the forward tube. The filament wound fiberglass.
So then, I'm going to ask questions as we go, if you don't mind, just so I get
for sure. Absolutely.
So your forward airframe and your nose are kept together at apogee, and then as the rocket falls down to the lower main deployment, that's when the ejection charge fires, throws the nose cone, throws out your pilot chute, which then pulls your main out of the bag.
Absolutely right.
Okay. Is your pilot chute and your deployment bag physically attached to your main, or will they separate completely?
So they will be attached to the top of the bag. You can kind of see it's not super laid out, but yeah, it attaches right here onto this onto a swivel.
That's one of those things a lot of people forget about, and they end up with their deployment bag floating away on their pilot chute.
Yeah.
Yeah.
We flew a deployment bag at Spaceport last year, so we've seen that happen for sure.
Okay,
and
that's an excellent question. You guys obviously have competed before. Have anybody on the team that's going out this year, have they been out there previously?
Yes.
Okay, so I don't have to scare you about how bad the desert is. You already know.
Yes, yeah, we've been out there a few times.
Mine and Jack's third Spaceport. Have been since 2022. So
okay, then I probably owe you an apology because I probably yelled at you at some point in the field at one point or other. So,
oh, no worries.
Okay,
part of the fun.
Yeah. Anybody high-powered certified on the team?
Yes. So Jack and I are both level 2. A couple other members are L2. I'm actually working on my L3 right now. Just recently started speaking with my TAPS. So we got mostly everyone I think has an L1. We have 2 or 3 traveling with us that are just level 0. And then our flyer of record is an alum of the club who got his L3 cert. So yeah, we have a local prefect in Columbia. So our prefect head helps us out quite a bit.
Sure. Okay. When you're going through your flight safety review, make sure one of the first things you mention is the members of the team that are high power certified, because it's going to go a long way towards reassuring them that you guys have the basics of how to successfully fly a high power rocket already locked down.
Okay, for sure. It's definitely a good thing to mention, I guess. Yeah.
Okay, so you were moving on to your forward airframe.
Yes. So yeah, you can kind of see in here, kind of the same bulkhead idea that we have. I can just show it off on this other side with this steel eye bolt, and then the 2 threaded rods, 1/2-inch threaded rods that go throughout the entire middle section here. And I can take it out as well. It's got the terminal blocks, obviously for the main, and then redundant charge for the actual deployment of the drogue parachute, and then obviously the forward for the main deployment as well.
So that coupler with the eye bolt that you were just touching right now, that's got your flight avionics in it?
Yes, yes. I was going to pull that out to show you.
Yep, go for it.
All right. So yeah, we can kind of see how it all kind of is kind of two separate sheets of the fiberglass, just kind of for spacing purposes. It's about 7 inches long. We got the RRC3 and then the Stratologger there for the redundant flight computer, and then kind of the battery mounts and the two the I forget what they're called, the key switches to actually arm the redundant and the main computer that kind of sit on those threaded rods, and then goes against a bulkhead on the inside that is epoxied in as well. And then obviously the charges go on that side of the bulkhead, and then along our payload that's actually embedded in here to the other side of that bulkhead there.
So your payload is in that bay as well?
Yeah, it's on the upper half of the coupler section. Yes.
There's a bulkhead in the middle of that coupler that kind of separates the avionics and the payload, but yeah, they're essentially both inside that coupler itself.
Okay, is your payload deploying in any way, or is it just staying in the rocket for the ride?
It's just for the ride, yes.
Okay, what's your experiment?
So our experiment is actually a few kind of individual little kind of cups. We kind of want to make streamline the payload kind of design for more of like a plug and play kind of stack ability. So that kind of whole payload design was kind of new. We usually do the CubeSat challenge ourselves, but this year we decided to kind of run 5 individual experiments, one being kind of to show that we can power the rest of them using like the new lithium ion batteries system that we have to actually power a camera. Another one for 2 strain gauges to kind of test like the flight, like the forces that go across these 2 threaded rods throughout the flight to kind of see the moment kind of happening across this, because last time we tried to fly to 30,000 feet. We kind of had this as the recovery section of that coupler. So there was a lot of forces that happened across this that we definitely don't want to have happen again. So kind of getting that post-flight data for kind of the internal forces going this fast would be kind of interesting to kind of get that post-flight analysis, and then along with IMU data from our Arduinos to kind of see kind of if the forces of flight kind of match what our simulated kind of trajectories were as well. So along with that, kind of having there's also a carbon nanotube section there that one of our members is part of the research team, and he just wanted to kind of do some post-flight analysis on those samples as well. So they're all kind of little cups that sit along this section. I can take that out as well if you're interested.
No, that's okay.
I was gonna say, if you could just show them the poster.
The poster. Yeah, sure.
Poster.
It was for our capstone, so I can just kind of throw it over here.
So are you guys competing in 10K cots or 30K?
30K cots. I probably should have mentioned that. But yeah, so these kind of individual sections kind of stack on top of each other to kind of get one mass on the inside where they all kind of sit as the ceiling for the next kind of section there. So
how are you passing your deployment charge from your electronics bay through your payload bay up to wherever your charge well is going to be to deploy your nose cone?
Absolutely. So we have like kind of a braided 4-wire kind of housing that goes and passes alongside each of these little, you can kind of see these little divots.
Okay,
this was set aside just so you can get that cord all the way through. So
you've got dents in each of the experimental cups for the wire to run next to.
Absolutely.
Gotcha. Okay.
Absolutely. Yep. So yes, this will be the experiment that goes inside of that payload.
Now, are any of your experiments that are going in that bay pressure sensitive? Because when your deployment charge fires, it doesn't seem like those are going to be able to be truly isolated from the pressure wave. Is that the problem?
The carbon nanotube has its own little plastic housing, so I think that's the only one that could be sensitive to that pressure change. The strain gauges will be epoxied onto a little threaded nut onto the 1/4-inch rods, and then the IMU just kind of tracks kind of position data. So none of it is sensitive to that.
Okay.
Yep.
Good. Have you test flown the airframe at all?
We have not, but we have tested this design previously, and we do trust the commercial kind of body tubes. Along with that, we did do a little bit of a 3-point bending test on kind of a mock-up version of the coupler, just to make sure that these kinds of stress concentrations don't occur again. Obviously, this is the failed part. You can kind of see kind of where it broke along that. So when we were drilling those holes, we wanted to make sure we weren't going to compromise any parts of the rocket. So we kind of did a full stress test to see. I know it's usually a dynamic system, but we got to 15 kilonewtons of force across this, and it broke due to bearing stress, not any sort of hole failure across that. So we were happy with those results, and we're confident in this design and this reinforced coupler section itself. So we believe in the airframe for sure.
What
better than the whole concentration, I guess.
What electronics are you flying on? What are your flight computers?
So those that would be the. Oh, sorry. What?
Your flight avionics, not your payload.
Yeah,
absolutely.
I can talk about this if you want, Jack.
Yeah,
so
sure.
On the right there, we're flying the MissileWorks RC3, and then that's going to be our main flight computer. And then on the left there, we have a Perfect Flight Stratologger. So that's going to be a redundant. We flew an identical setup last year out at Spaceport, and we didn't have any issues. So we just figured don't reinvent the wheel, stick with what works for us. So,
and I would imagine 75% of the teams are going to be out there with RC3s. So yeah, that's by far the most common altimeter that are going into the contest. So that's great. Do you have a GPS unit or a tracker?
Yes. So we actually have two trackers. Normally we'll only fly one, but we had issues with our tracker last year, so we figured fly a redundant one just to be safe. So you can see they're actually both right there. I don't know. It's kind of hard to tell. So previously we flew just the featherweight GPS, so that's the one in the middle there. And so that has worked pretty good for us in the past. But this year we're flying the Altus Metrum Tele GPS as well. So that's our first time actually flying that flight computer, but we've ground tested it. Seems to be working fine. And I know that you guys out there are like, you can track the GPSs that use the APRS packets or whatever it is better. So that was definitely one reason we wanted to get one of those flight computers on there as well, or the GPS is on there. Sorry.
Okay, great. And how are you powering the whole units?
So each flight computer, you can kind of see the battery housings. Those are just powered by regular 9-volt batteries.
Okay.
So that's for both the flight computers, and then both GPS units, they're both recommended by their manufacturers to use LiPos. So we just stuck with those. I know that was the one exception to that rule that you guys specified with batteries. So both of those are just flying 1S LiPos, and we haven't had any issues with those. And, we flew the same LiPos last year. So don't anticipate any battery failures on those.
Any concern about heat?
So we should be okay. We did just do like a duration test of the batteries. We didn't do like a heat test on them. But the battery test that we did do showed us, like, I think the RRC3, it was like 11 or 12 hours, and the Stratologger was even more than that. I think it was close to 20 hours. I don't have the numbers pulled up right now, but those should be fine. And then previously
but were those that duration testing, what kind of temperature was that done at?
Yeah, that was just done at ambient lab temperatures.
So you guys do understand that the temperature out of the field is going to destroy that time, right? There's no way a LiPo is going to last 18 hours at 150 degrees.
And so previously in the past years of the competition, our GPSs, which are the things using the LiPos, those were just like plugged in before we even sealed the rocket. So back at where the assembly is done. But this year we actually incorporated those batteries onto the switches, so we can turn those on out at the pad instead of, back at base camp. So that way we'll be able to get more battery life out of them compared to years past.
Okay. And these aren't really hydro applications either. So, short of barring some sort of short happening, you should be fine even in such a warm environment as the inside of the rocket if it's sitting out there cooking in the sun for a couple hours because some other rocket has an issue before you can get yours launch.
Yep, and we plan on painting our airframe mostly white as well to avoid heat. White and green are our main colors, I believe, we're flying this year. So that will help with heat as well. Yeah, I don't
That's almost
anticipate.
a shame. That red fiberglass is damn sexy.
Yeah, and the same with the fin can. I'd love to keep
Oh
that
yeah.
aluminum exposed, but yeah, you got to do what you got to do.
Yep, yep. Okay, so that's your avionics. I think that's going to be fine. That's going to be in the coupler, and that point where your avionics is, that's where your rocket is braking at apogee.
Yes.
Yeah. Yes.
Okay, so
Popping off
so
the
your
ad.
drogue chute is actually in your booster section during flight.
Yes.
Okay,
Or well, so
Yes.
yeah.
Yeah, it's right there, and where Jack's pointing the camera at, right in the
yep, yep.
Yeah.
right
Okay.
above
There
the
you go. Yeah.
bulkhead down there.
Yep. So that bulkhead is actually a 1/2 inch fiberglass bulkhead. We kind of reinforced it because we have a lot of thrust with this motor, and so we really wanted to make sure that section was pretty secure. We also did a hydraulic press test with our normal West System fiberglass mill epoxy, and we were pretty happy with those results. I think we said we had a factor of safety of well, I think it was upwards to like 13. What the thrust we would get from that motor is. So that's if all the thrust was only hitting that bulkhead. So we're pretty happy with that being a pretty firm, secured point for the rest of the motor. That being said, we're flying an Aerotech N3300R, and it'll be in the RMS 98-560, I believe, which is going to be sliding into this aft section here. Yeah.
Okay,
And
can I
then
see your fin can a little more closely, please?
yeah, absolutely. So this is a Max Q Aerospace fin can from It's made of aluminum 6061. We slightly modified the kind of like we cut off some more fin for fin flutter analysis purposes to make sure we didn't hit those speeds or kind of that damage. So it's slightly modified. Excuse the dirt from the ejection charge testing, but yeah, other than that, it is got these aluminum kind of plates that go around and kind of grab onto the motor, and then the actual fin can is mounted there.
So other than the ribs that are bolted to the fins, I noticed that the fins extend a little bit farther forward from the fins. Is that just sitting up against the
So
airframe, or is that embedded in some way?
So it is embedded into the airframe, obviously to avoid the any sort of movements or I guess rotational movements. So there's 3 fins here. They each sit and like are held in by that airframe as well, just to kind of stop that rotation, if any. So that's kind of how it's embedded into that, and then obviously also retained by this motor retention. Very snug fit there as well. So,
and your retainer is just a screw on?
Yeah.
Yes. Yeah.
It's standard Aerotech casing motor retainer.
Yep. Gotcha. Okay.
Yep.
Jack, do you want to show him the launch lugs, that bracket?
Oh yeah. So speaking of that bulkhead, that very thick bulkhead allows us to kind of not do the screw. I guess this the kind of threaded into the airframe, so we didn't get any snags on the drogue parachute, because we often worry about that kind of being in the way for that deployment with the space kind of constraint. So this is actually it bolted into that actual bulkhead. And then back here, we actually have a similar system where it's actually also attached to the fin can itself there with that plate. And they are lined up fairly well.
Okay. And you're only using 2 lugs?
Oh, yes.
Good. Okay.
And that bolt still needs to be trimmed down a bit.
Yeah. We'll make sure that fits for the 1550.
Yeah.
Yeah, because that was going to hang up in the rail. You're right.
Yep, absolutely. So that's probably, you asked if we were able to launch this weekend. If we just cut that, we'd be ready to go. So
sure. Do me a favor, unscrew your retainer for a minute.
Okay, for sure. Just one moment. Who tightened this? Yeah, let's switch. Yep.
Is there any chance that your retainer was already in place when you tightened down the bolts on your fin cam?
That is what I'm thinking, because it is a little stiff to get off right now.
Yeah, if you can't get it off, that may be the problem. What
Okay.
is that you basically compressed the end of the tail with those bolts on the fins.
Yes, I believe that. We can try to.
Either that or somebody made a mistake and epoxied the thing in place. I hope that's not.
No. We installed this the other day. No, I promise you we take it off. I think the yeah, like you said, those bolts kind of aren't keeping it from spinning off easily, I guess.
We can move forward even with it left in place. What I want to come to understand better is force transfer. Obviously, your motor is got a flange on the ass end of it that hooks into your retainer. And
yes.
then how is the force of the rocket's thrust moving through your rocket from that flange on your retainer out to the outer airframe of the rocket?
Okay, for sure. So like you said, if this fits, you can kind of see kind of it pressed up against that fin can, like it is. When it's fully on and compressed down, I guess evenly, it definitely transfers. Like this is a very thin gap here, and along with that, as previously mentioned, that bulkhead kind of getting all that thrust as well allows it to kind of hit the outer airframe.
So move back to the retainer for a minute.
Yep.
Maybe I just want to see. So the knurled section of that retainer, the part that you would grab to unscrew it, is actually proud enough that it is seated up against the aluminum pieces of the fin retention?
Yes.
Okay, now there is a metal piece forward of the knurled section right there that your finger is just touching.
Yep.
Is that part of the
fin can
airframe, or is that part of the fin can?
So that's part of the fin can, but the lip there as well, you can see that it really is pushing into that airframe. So any thrust from that kind of retention ring will push against the fin can and then push against the airframe itself.
Okay, then there looks to be an additional piece of metal between the fins that your rear centering or your rear lug is sitting on.
Yes, yeah. So this is the bracket for the lug itself. Just because we didn't want to go through the motor, obviously. So this is kind of an external piece of hardware that we have.
Gotcha. Okay, I'm with you now.
Yep.
And
so I could look at the other side as well. Obviously, no plate there, but same idea on each side of that fin can there.
Okay. Other than trying to figure out a scheme that you can get your retainer on and off, I think that's going to be fine.
Yep.
Now, if you look at your rear lug,
yes,
it looks like it is standing fairly proud of the rocket itself, regardless of the nut that needs to get trimmed off at the top of the thing. It looks like it is standing farther away from the airframe than your forward lug. Am I seeing that wrong? And they are the same height?
We did put a washer on that front one.
Yes, you are seeing that right. I am actually laying down new launch lugs here with a bigger chamfer here, and then also we'll set that nut in. So I'm aware of that. I'm just making the new one.
Okay, fair enough. You can go either direction. The issue is that you want your rocket to be parallel to the launch rail instead of having the nose rubbing against it because your upper lug is a little bit shorter than your lower lug. You know what I'm talking about?
Yeah.
Okay. Absolutely. Yeah, you want them parallel to the rocket.
Yeah.
Of course. Yeah. But yeah, I think that pretty much is the fin can. Obviously, we've got replacement screws. Hopefully, the desert's nice to us with those screws. But yeah, we'll definitely get a system in place to kind of make sure we set that up so we can get that retention ring in there as well. I guess any other prominent questions? I'm making sure we went over most of the sections. And then all of those eye bolts as well are Loctited in as well to those bulkheads, along with those terminal blocks as well.
Okay, and now you showed me that one eye bolt, and I'm assuming there are others within the rocket, and they're all
Yes.
welded
Yes.
solid eye bolts like that. None of them are just bent into shape.
Yes, yes.
Yeah.
I can also take off the section, but it's an
No,
identical.
that's all right. You don't need to. It's just
section,
as long as you're aware that they need to be welded, you're in good shape.
Yep, absolutely.
Okay.
Yeah, we like the steel ones. So
approximately how long is your shot cord on your main?
I believe, Ryan, we said
I think it's around 36 feet. I almost said inches.
36 inches
Yeah.
was going to be worrisome. 36 feet
that would be bad.
with, yeah.
Yep.
And your shot cord on your drogue?
I think that's roughly 24 feet.
Okay.
Yes, that's
Are
right.
you going to mount your drogue chute halfway up that cord or offset it to one side?
The knots have already been tied into the rocket. I think it's offset right now.
They're offset. They're offset. They're tied at 1/3 of the length for both.
Okay. Did I just hear somebody say it's tied at 1/3?
Yes.
Okay. The concern there is that you don't want, while it's coming down under drogue, and obviously the front and back of the rocket are going to have an opportunity to move around and swing a little bit underneath that chute.
Yep.
You just don't want them slamming into each other because the shot cords are the same length.
Yeah, so we laid everything out as it would, in our hallway, and then we picked where we want things to go, like where to tie the parachute knot at from there. So then since we laid everything out, we were kind of able to tell, like, okay, this would probably swing here, and it would avoid the airframe or what have you. And we have pictures of that as well, of us doing that.
Okay, and you mentioned earlier you've already ground tested your deployment charges?
Yeah.
Yes.
Okay. What are the things that you guys feel you're not ready to fly with? What do you still have left to do before you can head to New Mexico? As far as completing the rocket, I'm not talking about packing and getting ready for the desert and stuff like that, but getting the rocket prepped.
We want to make sure that we have like kind of our packing checklist just in case we need anything out there. But of course, that launch lug back there, we just need to make sure that, like you said, those line up and are ready to go. But we have Sirius working on that around the clock. Hopefully getting that done so we can mount that securely and make sure that is good to go. Along with that, making sure that any sort of avionics, I think we're all good to go there, Ryan.
Yeah.
If I'm correct, we still can do that heated drain test if we have other LiPo batteries and 9 volts. But other than that, I think the simulation and testing has proven that we're good to go with the airframe we have and all the kind of shock cord and parachute layouts kind of work out. So I don't know, Ryan, is there anything that you think really painting?
Just that rear launch lug is the only thing really stopping us from being ready to go. Everything else is pretty much done. So.
Okay. And it looks to me like you've got a nice build here. Once I'm finished with this, with our conversation, I'll be reporting in that you guys are ready to go as far as your rocket's concerned, which gets you past your 3rd progress report. So congratulations on your work so far. I think you guys have put together a nice rocket, and I'm really looking forward to seeing it fly out in the desert this year.
Awesome.
All right. Thank you so much.
Do you see any glaring issues that would, get us stopped by, the safety review at the competition, or like anything we should be wary of, I guess?
Looking at your altimeter bay, your altimeters themselves are powered by 9-volt batteries, correct?
Yes.
What brand are they?
They're just the Amazon Basics brand.
The problem with a lot of different brands of 9 volts is that the internal components inside the battery housing are simply press fit together. And in the high G load and high vibration environment inside the rocket, those parts can separate and lose contact with each other. Duracell 9 volts are soldered internally. I would strongly encourage you to pick up a couple of sets of Duracells and use those, because they're generally considered to be the most reliable types of 9 volts for this kind of application.
Gotcha. Okay. And
hey, this is Kendall Feist, the flyer of record. I have taken apart some of those Amazon Basics ones, and they were soldered together.
Oh, great. If you're comfortable they're internally soldered, that's great. I've never pulled one apart. I've just used, normally comparing that to some of the other brands out there. So that's great.
Well, that being said, it might be worth, I don't know, it's possible they changed their manufacturing process in the past couple of years, so it might be worth doing it again. Or just buying the Duracells.
Yeah, you're not talking a big expense there either way. So
Yeah.
Yep.
All right. Well, that's something we'll look into for sure.
but I do not see anything that's going to be a real showstopper. It looks like you guys have a solid rocket put together. I think your flight safety, unless they see something that I simply can't tell over the camera,
Yeah.
everything looks like it's in good shape. You've thought through your build, and you should be in good shape.
All right. Perfect.
All right.
Oh,
Check.
charge wells.
Oh,
Where
yeah.
are you loading your black powder?
So I don't know if Jack's on standby
yeah, I
there.
can
So
grab-
we actually don't use like charge wells on the bulkheads themselves. We found success in just using pretty much just little like 4 milliliter plastic wells that you would see in like a science lab or what have you. I think Jack is grabbing some of them right now. So we essentially just drill a hole through the bottom of those little plastic tubes. We stick our E-matches through the bottom of those holes, hot glue that hole shut, pour the black powder into the tube around the E-match, and then fill the extra space with dog barf, and then just put the cap on the well itself, and then just put a piece of electrical tape over the top. Yeah, there's one made right there.
Okay.
Yep.
And that's great. I am much happier with that than I am the hard mounted charge wells that I see on so many rockets, because ultimately, if you're using a hard, especially a metallic charge well, basically what you're doing is firing a shotgun shell into your parachute bay when you set that thing off.
Right. Yeah.
Mm-hmm.
And the directional thrust coming out of those hard bays is never a good idea for your internal componentry or your chutes or your cords or
Yeah.
anything. So having this type of, that whole container is obviously going to fracture, and so you will have a fairly omnidirectional forces coming out of that charge, which is exactly what you want.
Yes.
Yeah, those E-matches just get screwed into the terminal blocks on the bulkhead itself.
Yeah,
so.
that's no, I like those. I think that's a great idea. Okay. I am not coming up with any additional questions. Do you guys have any questions for me?
I'm good. I do see we have a minute and a half left on the Zoom call. It's ticking
Oh,
down. So
I do have a quick question, just real fast. I know Ryan mentioned kind of painting over the kind of aluminum reflective fin can. I think I looked over the D-tag, and I think I couldn't remember if I found anything saying we couldn't have exposed metal like this. Would you recommend that we paint over it?
I apologize. I don't recall from the D-tag that there's anything against there being exposed metal. I don't remember there being anything about that.
Okay.
So I think you would be fine leaving it as is.
Okay.
And the worst case happens, you get to your
we
flight
just-
safety and they say, hey, go grab a can of white spray and paint the damn thing before you fly it. And just, you may have to do that, but you could do that outside the hotel or out in the field without any problem. So I don't see there being any problem if you just want to leave it as bare metal. I don't think that'd be an issue.
All right. That sounds good to us. All right. I think that's all the question I have, I guess, for this one.
All right, guys, well done. Real nice project. Now, how many folks are coming out to the launch with your team?
13.
No, we have 14 students, and then Kendall's driving.
Oh,
down
yeah,
with
I
us
guess
as
15.
well. So 15 total.
Okay. Great. I'll have a safe trip, and I look forward to seeing you guys out in New Mexico.
All right.
Awesome.
Thank you so
much.
All right. Thanks for starting this up early for me. I appreciate it.
Sorry for being late.
No, it's no problem. Thanks a lot.
Thank
All
you.
right.